Hello everyone, and welcome to Novell Design Studios CAD division. For demonstration purposes, I will be making an eternity band for 3-point diamonds. Let's start by making our finger size curve of 16.7 millimeters. And our curve for our tube for our diamonds. We will make this 2 millimeters. Even though a 3-point diamond is usually 1.9, we want to allow a little bit for polishing and shrinkage. I'm going to offset this curve by 0.5 millimeter. Extrude this up as a solid, 2 millimeters high. Change it to this color so we can control it. We also want to make sure that it's 1.5 millimeters above the finger rest. There aren't big stones. We don't need too much metal above the finger. Right there is good. Let's get rid of this curve. Let's do a polar array, which should be 30 settings. Let's make our prong. I'm going to make this 0.6 millimeter. I seem to have come across this a lot over the years, especially in CAD designing, where it looks good in the CAD, but it really doesn't function properly in manufacturing. Let's extrude this now to 3 millimeters. Bring in our settings. Change it to this color. And raise it up over here. Let's rotate it to the intersection of the tubes. Let's bring it down from this top view. Now we're bringing our stones to make sure there's an intersection with the prong. Let's mirror this and do a polar array of our prongs. Let's hide the stones and boolean all this together. Watertight in computer world STL file. We will be able to export this as an STL file later for building. Let's extrude our finger size curve to make a cutter. Let's do a Boolean difference, which actually means cutting out the center of the finger size. And in a couple of minutes we have what appears to be a proper CAD design of an eternity band. I am going to produce what I think is one of the proper ways to make an eternity band, and point out what's wrong with this when I'm finished with ours. Let's start with our curves again. Again, 2 millimeters. Let's offset this 0.3, which will be the top table, 0.5 where the diamond will sit into, and 0.65 which will be the bottom plate. Let's rebuild this to 10, change it to blue so we can control this later, and raise this up to 2 millimeters. Bring the diamond seat down 0.35 millimeter. Project this down, not deleting the master curve. Now I want to bring these out and Now we will perform a loft. We want this straight. Let's preview it. Closed. Beautiful. Let's hide our curves. Change this to blue. And if we look over here in the front ghosted pane, you can see what's already happening on the bottom. It's thicker on the bottom. When we join these together, this is going to help keep this structurally sound. It's not going straight down because this tends to become the weakest point of the ring when it gets joined. Right now, let's raise it to the same height as the other Eternity Band. Hide the other Eternity Band. Let's do a polar array again. Now we have intersecting tubes over here, overlapping, and there is a reason for that. In a couple of minutes, we'll get rid of it, and you will understand why. This tube will split with these curves. Let's select all of the blue, keeping this, deleting that. Let's hide these curves. Again, let's do a polar array. And let's join these. Okay. Right now, let's hide it. Let's make our prong. Again, we will start out with a 0.6 curve. And we will make another one 0.7 and another one 0.65. And all these extra steps are taken to help produce a better functioning piece and something that is engineered properly. Let's raise this up 3. The thicker tube we want to drop down to near the intersecting points of where the diamonds are going to be in the ring. And there's other parameters and ways to go about this. I'm trying to shorten up this video so you get the concept of what's going on. Let's do a loft with these curves. This we want normal. Let's change this to orange so we can hide it. Also, I'm going to cap this with a dome. And the reason for that is whenever you have a flat area, whether it be in metal or in wax, anything that's hot when it tends to cool will get suction. And this dome helps for easier injection in the mold and easier casting in the metal. Now I'm going to join it with the base of the prong and cap this, and we will hide it. Let's delete those. Let's raise up our prong. Let's bring the diamonds in. And let's rotate this to the proper intersection also between the stones. You can see over here, again in the front pane that's ghosted, how the prong is wider where it's meeting the diamond and narrower on the bottom and narrower on top. But where it's important for its structure, it is thicker. Bring this down. Let's do a polar array again. We'll hide the stones. and do a Boolean. Also, when this is finished Boolean, let's change this back to blue. When you look close between the prongs, let's bring this a little smoother. It looks a little rough. Okay. In between the settings here, you'll notice it's closed. And in the original Eternity Band, you'll see a gap. Now, rubber will get caught in between this when they go to pull waxes. If the rubber doesn't get caught, eventually down the road, even by the customer, dirt will accumulate in this area. Also, the setting walls are straight down, and from underneath, this is only 0.5. This will tend to be its weakest area eventually and start stretching and straightening out. We will do a Boolean difference of this new Eternity Band. You will get a better idea to see how much stronger it is underneath without changing its appearance from the outside. And as we can see, underneath it's wider. On top, the wall is actually a little thinner with the teeth for the diamond, and this will be very sound for production, future wear, and even the stones for where the prongs are much stronger. Thank you very much for your time. I hope you enjoyed this tutorial.